a constant c. So if I take experiment 1, this means that 7.66 into 10 to the power of minus 2 over 0.05 to the power of m is equal to c. And now if I take experiment 2, I know that 1.53 into 10 to the power of minus 1 over 0.1 to the power of m is also equal to c, because it's equal to it's constant. The concentration of H2O2 to the power of n times k is constant for both these reactions, because k is a constant and H2O2 remains constant in experiments 1 and 2. So now, since both these terms are equal to c, I can equate them, and when I equate them, I get 7.66 into 10 to the power of minus 2 over 0.05 to the power of m is equal to 1.53 into 10 to the power of minus 1 over 0.1 to the power of m. So now I can calculate m, because I can keep both the m terms on one side. So this becomes 0.1 to the power of m over 0.05 to the power of m is equal to 1.53 into 10 to the power of minus 1 over 7.66 into 10 to the power of minus 2. Now if you look at the left hand side, I can also write it as 2 to the power of m, because if m is the common, if they are both to the power of m, I can take m outside the bracket. So 0.1 over 0.05 is 2. So this is 2 to the power of m on the left hand side. And on the right hand side, when I use my calculator to calculate this, I get something that rounds up to 2. So m is equal to 1, because 2 to the power of 1 is equal to 2. So m is equal to 1. So now I know that m is equal to 1. So I can clear this part, because now I've calculated the value of m and I know that m is equal to 1 using all these calculations. You can also use logs to confirm your answer, logarithms, which you studied in math. So it's not really difficult, it's very easy to do. So now we have to calculate the value of n. Because we have m, we have to calculate the value of n. So now let's just erase this equation, because we no longer need it. We have calculated the value of m, and we can write the general equation now as rate is equal to k times the concentration of AuCl3 to the power of 1. So I can leave it alone like this, times the concentration of H2O2 to the power of n. So now I have to calculate the value of n. I don't have to calculate the value of k, because they haven't asked me to calculate the value of k. I can leave k. The only thing I need to calculate is the value of n. So I can also rearrange this equation as rate over the concentration of AuCl3 times the concentration of H2O2 to the power of n is equal to k. Okay, so I've rearranged this equation like this now. Now we know that the rate over the concentration of AuCl3 times the concentration of H2O2 to the power of n will always be one value, because k is a constant. K is the same for all these all these experiments. At the same temperature, k is constant, so k is same for all three experiments. So now what we do is, now we will use experiments 2 and 3, because the value of H2O2 is changing from 2 to 3. So now let's use experiments 2 and 3 and write, for experiment 2 it will be 1.53 into 10 to the power of minus 1 over 0.1 into 0.5 to the power of n. So the 0.1 was to the power of 1 because we calculated the value of m as 1, and we can equate